So now let's look at graphing some exponential functions. So we're going to start with kind of our most basic exponential function, y equals 2 to the x. And we'll start by plotting some points. Remember, you can always plot points. You can always find points. We're going to look at some generalizations here. But remember, you can always go this route. So when x is 0, 2 to the 0 is 1. Anything to the 0 is 1. 2 to the first is 2. 2 to the second is 4th. 2 to the third is 8. What about negative numbers? 2 to the negative 1. Remember, that puts that in the denominator. 1 over 2. Or really 1 over 2 to the first. 2 to the negative 2 puts in the denominator 1 over 2 squared, which is 4. And 2 to the negative third puts that in the denominator 1 over 2 to the third, which is 8. All right, so let's go ahead and graph those, and we'll get a look at 2 to the x here. So we have 0, 0. Let's go ahead and label our axes first. Always good to put some labels on your axes so we have some perspective here. So we got some points 0, 1. When x is 1, y is 2. When x is 3, 2 to the third is 8. When x is 4, 2 to the fourth, which we didn't find, but it'd be a 16. Notice we're doubling every time, so it's going up pretty fast. It's not a line. It's a curve. Let's try that again. So we're going to draw that in as best as possible here. A little tricky to do it by hand. Let's go. There we go. All right. And then we have our negatives. When x is negative 1, y is 1/2. When x is 2, y is 1/4. So we got 1/2, 1/4, 1/8, 1/16. Is it ever going to touch that x-axis? Is it ever going to be 0? That's an important question. And no, it's not. Never going to be 0. It's going to get closer and closer. But we always have something there. So we'll always have half left. All right. So this is something that we call the horizontal asymptote. This line that it never touches. This line right here that it never touches, but it gets really close to. All right. So that's called the horizontal asymptote. So the horizontal asymptote is the x-axis in this case, and it's a line that it never touches. It gets infinitely close to, but it never touches that axis. All right, what about y equals 3 to the x? Let's investigate that one here. Y equals 3 to the x, so let's go on over here. X and y equals 3 to the x. Well, when x is 0, 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. How about negative 1? 3 to the negative 1 is 1/3. 3 to the negative 2 is negative, let's write it out. 3 to the negative 2 is 1 over 9. 3 to the negative third is 1 over the 3 to the third, which is 1 over 27. So remember, the negative exponent drops it downstairs, and then we do the power, in this case, the third. All right, so let's graph those. In blue here, we've got 0, 1, again, same point. But when x is 1, y is 3. When x is 2, y is 9. When x is 3, y is 27, somewhere way up there. So it's increasing very quickly, even more quickly than 2 to the x. And what's happening down on the bottom? We have negative 1 gives us 1/3, which is less than a half. Negative 2 gives us 1/9, which is lower. Okay, and again, we're cutting it down by 1/3 every time. So it's, again, never going to touch this axis, but you'll see it's below the red line, below 2 to the x. Okay, but it's never going to touch it. Again, it has a horizontal asymptote. Okay. All right, so this is y equals 3 to the x, and this red one is y equals 2 to the x. So you can see that 3 to the x is steeper, 4 to the x would be even steeper, 5 would be even steeper, and then they cross when they get down here. So those were bases that were bigger than 1. So what happens when we have bases that are smaller than 1? So let's try 1/2 to the x. So 1/2 to the 0 is 1. When x is 1, 1/2 to the first is 1/2. When x is 2, 1/2 squared is 1/4. And so on and so forth. All right, that's good enough. It's going to be 1/8 and so on and so forth. Okay. When x, well, I'm going to put that one in there, 1/8. How about -1? Well, what is 1/2 to the -1? Well, that -1 flips the fraction, and so we'll have 2 to the first, which is 2. If we have 1/2 to the -2, well, that's going to flip the fraction. It'll be 2 squared, which is 4. And one more, 1/2 to the -3rd. It's going to flip the fraction, make it 2, or 2 over 1, to the 3rd, which is 8. Okay, so this is really 2 over 1, maybe we should say. Okay, there's our points. Let's graph them here in green. So we have 0, 1. I'm going to go to the left first. We had -1, 2, -1, 4, -2, 4, that is, and -3, 8. And if we did -4, it would be up here at 16. Does that look familiar? Well, it's a mirror image of that red graph. This is y equals 1/2 to the x. Okay, so it's flipped over here, and we have 1 is at 1/2, 2 is at 1/4, and 1/8 for 3, because 1/2 to the 3rd power is 8. And again, never going to touch this x-axis. It's going to get really close. All right. So I think you can tell what's going to happen there. All right. For our next one here, we've got the 1/3 power. All right. So it's going to go, I'm not going to crank out the points, but it's going to look like this: 0, 0, -1, 3, -2, 9, -4 would be 27. I'm sorry, -3 would be 27 up there. Okay, and again, it's just this 3 to the x flipped over the y-axis. So this is y equals 1/3 to the x power there. And down below here, it's going to be 1/3, 1/9. It's going to actually be below this green graph there. But again, it's never going to cross the x-axis or even touch the x-axis. Okay. So there you have it. All right, so we get, these are exponential decay. They're going down to the right, the green and the purple one. Then y equals 3 to the x and 2 to the x are exponential growth. They're going up to the right. And the larger that b value, the steeper that's going to be. All right. So that's what those functions look like. Now we're going to see how we can move them around the axis. What happens when we add numbers to it? So let's investigate how we can change the shape of an exponential function and its graph. So to do this, you can use a graphing calculator. We're going to type in a bunch of equations here, or you can go to Desmos on desmos.com and use their graphing calculator, and you can graph these on the graphing calculator. A little easier to see on a computer there, or even a device. You can use their app as well. Or you can use this QR code here, which will use this pre-set up tool that I made that we can explore this, okay? So we're going to investigate some different bases to start here, all right? So the first question we want to know is what happens when we change that base from 2 to 1.5 to 7, so on and so forth, okay? So looking over here at this Desmos exploration here, so we have 2 to the x, and I'm going to change this b value. You can see the equation over here will change, all right? So watch that equation and watch what happens to the graph as we change this, okay? So we saw that as we went from, here's a b value of 2 to the x, and as we went up to 3 to the x, it got steeper, right? You see that? The right side's getting steeper, 3 to the x, 4 to the x, 5 to the x, okay, all the way up to 10 to the x. Okay, it's going really steep because this is multiplying by 10, all right? So over 1, 10 to the first power would be 10 way up there. And then it's multiplying by 10 every time. So that kind of makes sense, hopefully. What happens when we get smaller? So let's go down to 2. And here's 2 right there. Okay, that's 2 to the x power. And as we get smaller, notice it's getting less steep. There's 1.5 to the x right there. And then we're getting less steep, less steep, less steep. And 1 is just going to be a flat line, which we said that we can't have, that's not really an exponential function. It's just a line. But what happens when we go below 1? Well, we graphed, a few moments ago, we graphed a half, 0.5x, 0.5 to the x, there it is. Okay, and so you'll notice it's flipped over there, and 0, it disappears, all right? So between 1 and 0, we get exponential decay. Okay, so 0.1 is a real quick exponential decay because it's 1/10. Every time we go to the right, it's 1/10 or 0.1 of what it was before. So whatever it was here, it's 1/10 of that, 1/10 of that, 1/10 of that in height. So that's what the b value does, all right? So we can see that in general, just getting some rough sketches. Oh, one more thing here. Notice this. What point do those always go through? Did you notice that? So notice they always go through the point 0, 1. So it doesn't matter what that b value is. If it's just some number to the x power, okay, it's kind of doing a little workout here, all right? It's going between, it always goes through the point 0, 1 if it's just b to the x power. So 0, 1, 2 to the x is going to look something like this. 1.5 to the x is going to be a little less steep. Okay, because it's closer to 1, which is that flat line. 7 to the x is going to be really steep. Okay, now 0.3 is between 0 and 1. So that's like 3/10. So this is exponential decay. We know what a half looks like. All right, so 0.3 is going to be a little steeper than a half of that. 0.5x to the x. 1/5, well, 1/5 is 0.2 to the x. 1/5 is the same as 0.2, so that'll be even steeper than that 0.3. All right, so that's kind of the idea there. Well, what happens if we take and we add something to that x value? So let's leave the base at 2, and let's see what happens when we add or we subtract to that exponent. All right, let's see what happens there. So we're going to set the b value at 2, and we're going to change this what we call the c value. All right, notice what's happening to the equation. We're getting plus 5. That's this number here, plus 5. And watch what's happening to this graph. You see what's happening? It's moving, huh? It's not really changing shape. It's just moving. So there's -4, -5, x minus 5, x minus 7, x minus 8. All right. And you notice that point that I have labeled? Normally, the graph goes through 0, 1. And it has that shape for 2 to the x. But then as we move it, now it's going through 5, 1. Why is it 5, 1? Well, that's because of this number right here. Okay? So what's happening? Well, when it's x minus, it's moving to the left. And when it's x plus, it's moving to the right. You may have seen this with other functions, like quadratics, right? So other functions behave the same. When you add to the x, it goes left. When you subtract to the x, it goes right. Okay? And that point, this doesn't have a vertex like a quadratic, but we're going to kind of, you might think of that 0, 1 point as the quote-unquote starting point. Okay? So if we have plus 2, it's going to go left 2. And we're going to get that same shape. If we have plus 4, it's going to go even farther over here. This will be at negative 4. This will be at negative 2. If we have minus 2, it's going to go right. And that key point is going to be over at 2. And then over at 4, if we have x minus 4, that key point will be over here. It'll have that same shape as 2 to the x. Okay? That's the idea. How about minus 7? Well, even farther over here, right? Okay. Same shape. These all should be the same shape. I know we're freehanding, but they all have exactly the same shape in that row, but they're just moved left and right. And last one here, what if we move it, we do plus 2, plus 5, minus 3, so on and so forth, after. Notice these are in the exponent, these are outside the exponent. So let's leave 2 to the x alone and just change this value. We'll call this the d value here. So I'm going to put the c back to 0, all right? So we don't want to add anything to the exponent. We got 2 to the x there. Now I'm just going to move this d value. Plus 1, plus 2, plus 3, plus 4. Is it changing shape? Doesn't look like it. But notice that x-intercept is changing. Okay. And notice, remember, if we go back to 0 here, remember this is an asymptote right there. Now if we move this up here, where's the asymptote now? Well, the asymptote, the line that it doesn't cross, notice it's getting really close to, is at 3. Move it up a little bit more. Now the asymptote, the line that it doesn't quite touch, it gets really close, is at 5. That line is at 5. The point it crosses at is 6, which is one above. Okay? So, again, it's all about relating to this is called the parent function, 2 to the x. Okay? And we see that it's got an horizontal asymptote. We see that this point that it crosses is one above. All right? One above 0, 0 in this case. All right? Or if we move it up, all right, then we have the fact that the asymptote is at 3, and it crosses one above that 3, which is at 4. All right, so I think we're getting the hang of it here, all right, hopefully. So if we have plus 2, well, the whole thing is going to move up 2, and our floor, our asymptote is going to be at 2. It's going to cross one above, and the shape is going to be the shape of 2 to the x. If it's plus 5, we're going to come up here to 5. Our asymptote will be there. It's going to cross one above. It'll be the same shape as 2 to the x. If we have minus 3, we'll come down here to negative 3. We'll have an asymptote. It's one above. And there we go. Okay. And if we got minus 5, okay, then we'll have that. Now notice, by the way, these are always going up to the right, okay? Unless they were exponential decay, then we're going down to the right. So there's one number that we'll come back and investigate here in a second. That's this a value here, all right? So let's investigate that in a moment here. But what did we just notice, all right? So the b value changes the rate of growth or decay. So it's growth if b is greater than 1, or decay if b is less than 1 but greater than 0. All right, so that's going up to the right or down to the right. Decay is going down to the right. Growth is going up to the right. Okay. The H value moves left and the right. Okay. It moves left and right. Left if it's positive, or right if it's negative. All right. So keep that in mind. Okay. And then the last but not least, the K moves it up if it's positive, or down if it's negative. Okay. So left and right are opposite. Left is positive. Seems like left should be negative, but it's not. Okay. Up and down are exactly what we expect. Positive up, negative down. What about this A value? All right. Well, let's go back to this real quickly here. All right. And let's investigate if we add an A value here. So I'm going to bring this down to 2 to the x. All right. And what happens if I multiply this times negative 1? Okay, so this is negative 1. I've got to change this. This is now negative 1 times 2 to the x. See what happens there? It goes upside down. Okay. What happens if we make this negative 2? Well, if we go negative 2 here, let's go negative 2. It's going to go down also. Negative 3, negative 4. It's going to go down even quicker. Negative 5, okay? And in fact, notice this, when we haven't gone left or right, if I have negative 5, which this is, again, negative 5, this equation is not changing there, all right? So if we have negative 5 times 2 to the x, where does it cross? It crosses at negative 5 there. See that? Okay. So this gives us our starting value. All right. And we saw that before. So that's the same as what happened like with the penicillin if you watched the other video before this. Okay. If we have 3 times b to the x, so if we put a 3 in here, 3 times, notice this graph crosses at 3. So this is the starting value. It makes the whole thing go a little bit steeper. If that's negative, it flips it upside down, right? So that A value is the initial value. And if it's negative, it will flip it. So we call that the initial value. It changes the steepness, okay? So it will change the steepness. And it flips the graph if it's negative, if A is less than 0. All right? So, a lot of stuff going on there. We'll stop that there. We'll do a couple examples in the next video there. So that's how we can know where the graph of an exponential function will be and what it will look like.